Understanding the structure of an amino acid, how they interact with the solutions they're in, being able to identify the properties of the R groups, that's all well and important. But really, we need to now be able to build up from our amino acids, our monomers, to our polypeptides and proteins. How that goes together is just like we'd seen with our carbohydrates. We take our monosaccharides and have that ether formation, so that condensation reaction between two alcohol groups to create that ether bond or the glycosidic linkage. We're going to do the same thing here. We're going to take separate amino acids and we are going to have a condensation reaction between two of the functional groups. We will release water and form a new bond combining those two amino acids. Organically speaking, we're making an amide. Biologically speaking, we call that a peptide bond because we are building a peptide. So again, language and who our audience is. Organic chemists, we would call it an amide. Biochemists or biologists, we would call it a peptide or a peptide bond. What we are looking at is the reaction between the carboxylic acid of one amino acid to the amino group of another amino acid. Here, if you would want to, you can pause the video and try to identify which amino acids these each are. How you would do that is find that R group. So we know we have to have that nitrogen and carboxylic acid. We know we need that hydrogen, which means that it's that other group that gives it its identity. This first one is the only one that is not a chiral compound. This is going to be our glycine. And then the next most simple compound that has that methyl group is alanine. So we're going to have this reaction, and because it is a condensation reaction, that means water needs to be released. We are going to take off that oxygen off of that carbonyl. We're going to take off our two of our hydrogens so that we release water. When we do that, we form the amide. So here's that water, and that water came from the reaction of that carboxyl group on our glycine with the amino group of the alanine. There we have our amide. So this is our amide linkage, our amide bond, or the functional group amide. And then we can keep adding on new amino acids for each new, to build onto our polypeptide. When we look at this structure, we want to identify where the amide bond is because that's going to help us read the direction. So here we have that amide bond. I always like to orient myself, especially if you're going to be looking at images online, because people will just put amino acids together to make these peptides, and you really need to orient yourself. So the way I do this is I find my separate amide, so that means that carbonyl and nitrogen that are together. Then I orient in the no direction. That no direction means the nitrogen to the oxygen. No. Is it in the correct direction? No, which means yes. All right. You guys asked for my kookiness. Now we know we had glycine and we had alanine. We made that amide, or the peptide bond. When we start to build these peptides or bring amino acids together, how we will write the names is based off their 3-letter codes. You do not need to have these 3-letter codes memorized. They will be given to you with the structure of the amino acid. So glycine is GLY, and then we use a dash to show that peptide bond, and then alanine is ALA. Because there's 2 amino acids here, we say that we have formed a dipeptide. Like we did with our carbohydrates, where we can take a monosaccharide and build up to a disaccharide, or a trisaccharide, oligosaccharides, and then our polysaccharides. We've got these levels based off how many monomers we put together. Same process with our aminos, or our proteins. What we just saw was the dipeptide, where we bring two amino acids together to form that peptide bond. As I had shown you previously, we use the 3-letter codes to distinguish the order of each of those amino acids. They can be a 1-letter code as well. So typically when you're looking, you're going to get the structure of the amino acid. You're going to get its full name, the 3-letter code, and the 1-letter code. The 1-letter code is really important when you have really big proteins that we want to classify and we want to structure, because we just need to combine all that information into a smaller space. So that's where the 1-letter code comes in easily. Tripeptide, 3 amino acids. Then we go up to oligonucleotides, and we don't need to really stress about the difference between each of those, but those go up to 50 amino acids. A polypeptide versus a protein. So anything bigger than 50 or more amino acids starts to be classified as a polypeptide. What's different between a polypeptide and a protein is the protein has a function. It's got a name, it's got a very specific structure, but it's a polypeptide. Like in carbohydrates, we have our polysaccharides. We had amylose, amylopectin, glycogen, and cellulose. That is the same concept here. They were all polysaccharides, but they each had their own name or role of that carbohydrate. We will go over specific proteins later, but just kind of giving you that language as polypeptide doesn't have its function yet. So it's just building that sequence of amino acids. And then once it gets folded and has a role, then it becomes that protein. I challenge you, if you should accept said challenge, to pause the video and find each amide linkage or peptide bond in this structure. Name this growing peptide. How many amino acids does it need to have with its number of peptide bonds? All right, let's do this. Look for that carbonyl and nitrogen right next to each other. So that is 1 amide bond, 2 amide bonds. So that means we have 2 peptide bonds, and in order to make 2 peptide bonds, we need 3 amino acids. So this is a tripeptide. Looking at our R groups, I'm going to highlight them so we know what we need to look for. You would need to pull up your amino acid chart, whether it's from a previous podcast, in Alex, or on your guided practice. So the R group that has a CH, that's directly bonded to an OH, and a methyl group, this is called threonine. I don't know if I'm saying that right. Here we've got a CH2 bonded to a CH that then is branched to 2 methyl groups. This is called leucine. And then we have this phenyl, or this aromatic, with this carbon group. This is phenylalanine. So we added a phenyl group onto the alanine, which was a CH3. Oh, they're so creative. When we put these together, we're using the 3-letter combo. We have THR, LEU, and PHE. And that's how we would represent this tripeptide.